Hello guys, welcome to the channel. Today we will be solving this problem of the day in Leetcode. Today is 19th Jan 2026. So let's read the problem. We will solve the problem from scratch. I will explain my intuition. We will learn some techniques over here and we'll see how to solve the problem. Okay. So let's first read the problem. We are given an m cross n matrix and an integer threshold. We have to return the maximum side length of a square with a sum less than equal to threshold written if there is no such square. Okay, I think the problem description is very self-explanatory. So we will not go through examples. We'll directly jump onto the approach. So let's see how do we solve it. Okay, so we are given an m cross n matrix, right? So let's imagine the matrix uh, like this, and we will have some numbers over here. Let's say anything like 1, 2, 3, 4, 8, 9, 10. I'm just writing these numbers. 0, 1, and 2. Okay. Now we have to find a length of the square where the sum of that square grid is less than equal to threshold. Okay. So how do you find that? Okay. I cannot explain that properly. I don't know. Um, okay. So now let me stop and think once again. How will I go through it? Okay, so let's solve the problem. As you can see, the problem description is very much self-explanatory. So we will directly jump on to the approach. So basically, we are given a grid like this, and we have to find a square of length x such that the grid the the grid of length x is a square and its sum is less than equal to the threshold. Okay, so the whole sum should be less than equal to threshold, where sum is the sum of elements of the square. Okay, it's just sum of elements of the square of length x. We have to find such an x such that the sum of elements in that square of length x and square of side x will be less than equal to threshold. So directly jumping onto the solution, as we know that there are we can imagine any square in the given grid. Okay, for example, we can choose this 3 cross 3 square. We can choose another square called this. Okay, this is 4 cross 4. Okay, and in such a way we can find out which length is better for us. So there are two types of approaches we generally use to solve some of the problems of the same kind. So there are two techniques. One is linear search, and other one we called it as binary search. Okay, we will come on to why binary search works over here. Okay, now let's solve the problem. So first of all, we have to take an length x such that the sum of squares its sum of elements is less than equal to threshold. So let's imagine like okay, let's fix some of the let's say we fix a parameter called we fix this parameter x. Let's say this parameter x is 7. Okay, so let's say it is instead of 7, let's take it 4. Okay. Now we want to find out if there is an element, there is a square of side x in this grid such that its sum is less than equal to threshold. So what we can do is, okay, let's consider this. for each the grid position. Let's the let's say this position. Let's imagine a square offside 4 from this. So we will go 4 to the right, 4 to the down, and we get this. Okay. So if we sum all of these elements, the total sum should be less than equal to threshold. And if it is less than equal to threshold, we can definitely say that this is our answer. Okay, then we can check for 5, then we can check for 6, then we can check for 7, because we want the better answer always, right? So if we get an answer of 4, we will always look up to 5, or, or we will always look up to 6, or we will look up to 7. So uh, instead of traversing from left to right, logically we should traverse from right to left, right? So whenever, let's say if I got a square of length 6 which satisfies the given condition, then I can say that okay, 6 is my answer, then I don't need to check on to the left side. Okay, so we can break the loop over here. Okay, now what should we do? Okay, let's imagine okay, as we know that we will fix the length of the square grid. Okay, so if we fix the length of the square grid, what we want to do now? Okay, here we will learn what, let's say we choose an index. uh, let's say we choose the length, and then we want to check if there is a square of length x which satisfies the condition. We will what will be the brute force approach? Like we will go through each index of the matrix and then form a square of this matrix of that size. Like for 4 cross 4, starting with this index, it will be like this. For same square length, the same square for the position, this one will look like this. And for the other one, let's say if we start for 5, okay, it will look something like this. Okay, it is 4 cross 4, so we will use this. Okay, so now our problem simplifies to, if there is an element, there is a position where we form the square of length of side x, and if we get the sum less than equal to the threshold or not, right? So let's see how to solve this problem correctly further. Okay, now to as we saw the brute force approach, like first we will fix the length and fix the length x, and for this length check if there is a valid square. There is a valid grid. Okay, now to to check if a square is square grid is valid or not, we will require its left topmost point, right? Like from where the square would start. So as we saw that for this example, we started the square from this to this, right? And for 7 we started from 0 0 index, right? So we will require uh, two positions ing, so a grid position, so which will be our starting point, and then we have to find out, we will form a square around it. Okay, so how will the square will be formed? Okay, so logically we can say that okay, we have, let's say this is the square of length x. Okay, this is x, this is x, this is x, this is x. Okay, we have this point I comma j. What will be this point then? It will be I comma j plus x. And what about this point? this will be uh, this will be I plus x uh, and j plus x. Okay, and what about this point? This point will be the I it will be I plus x comma j. Okay, now we are clear that we have to find for this ij we have to calculate the sum of this square which is bounded by these things. Okay, now what to do? So we want to find out the sum of this square grid, right? In the so basically in this section, in this let me erase this. It's I want it here. So we can say that let's imagine a 3 cross 3 square from 1 comma 1. As you know that this index is 1. So for the what to we have to calculate the sum of this I mean this square, right? So to do so, we can just write a loop just like we traverse in the grid, right? Like for int I is equals to let's say it will be I1 is equals to I1 less than equals to see this. This will be I plus as we saw that this was I comma j plus x, right? So the columns the column threshold is j plus x, and for the row threshold is I plus x. So for row we will traverse from I to I plus x. Remember, mind it, like this is not an enclosed range, so we can say that it will be less than that I plus x. And for the column, it will be from j to j plus x. Again, it is not enclosed. This is a square, and this is circular bracket. Okay. Now, further, what should we do? Okay. As I said, our I1 will our row will start from I and it will end at I plus x. It should be strictly less than, okay, because we saw that it was not included. So this will be I plus x. This is I1 plus plus. Okay, and we will do another loop. Int j1 is equals to j, j1 less than j plus x, and j1 plus plus, and we just want to take sum of it, right? Sum plus equals to um, what is that? Mat of I1 and j. Okay, now as we saw, like first we fixed the length, so we traversed I mean we used a loop called length is equals to 1. I mean it will be some maximum value which will be minimum of n comma m, where n is the number of rows and m is the number of columns. Okay, so why am I saying that? So simple explanation is that for any grid, what can be the largest square that we can choose? Okay, this is m cross n, right? Here our n is number of rows, which is 5, and m is 1 2 3 4 5 6. Okay, so what is the maximum square we can get from this grid? Okay, if you imagine it, you will get to know that we can form at most a square of length 5 cross 5, a square of length 5. Okay, we cannot make 6 cross 6. It's self-explanatory, right? We cannot make 6 cross 6 like we have for this one, we can go maximum up to 5 only because we have minimum 5 rows, and here we have 6 columns, but only 5 of them will be matched with the columns, right? So that's why our best case answer will be the minimum of m comma n. Okay, now we will do length is greater than equal to 1, and then length minus minus. Let me write it clearly. It's length greater than equal to 1, and then length minus minus. And now we just under that thing, okay, we will choose I and j. We have to choose I and j, right? Firstly, so when I is equal to 0, I less than n, I plus plus, okay. And for this for loop, for the columns, we will also require j is equal to 0, j less than m, j plus plus. Okay, and under that, we will check if this is valid or not. Okay, if we got here, okay, after closure of this part, okay, uh, if we get sum less than equals to threshold, our answer will be length, and then we will never update our answer, right? Okay, now now as you can see, what is the time complexity of this code? This is very much uh, I mean very bad, so it will be n. So as you can see, this loop is going to n times. This is n, this is m, then this is again m, this is again n. So it is some kind of n raised to 5 complexity, which is not, you know, uh, surface, which will give TLE to us. Okay. So what should we do now? We have to optimize this furthermore. Okay. Let's try to optimize this thing. Okay. Because it is talking about sum, right? Sum of the square. So how can we find the sum of the square in an efficient manner? Okay. So we have to see if we can, eliminate this loop. Uh, let's eliminate this loop, then eliminate this too, then eliminate this too. Okay, this will be closed. Now here we just want to check if some of, as we know that our 4 points will be something like this. It was ij, it was ij plus x. We have to find out if there is a square of this size. Okay, what is the sum of this square basically? The square grid. Okay, what can we do is, now let's talk about the prefix sum. Here we require prefix sum to deal with that. So it comes with a new problem that, okay, we are given a grid. Okay, there will be some elements in that. Okay, let me draw it quickly. Okay, here we have some grid. Now we want to find out the sum of this, uh, the sum of the square, right? Square grid or anything. Okay, let's say for the sake of example, we have to find out sum of this square grid. Okay, uh, let's talk about this one. This is a 3 cross 3 square, right? Like how can we solve this, right? So here we use a technique called 2D prefix sum. Mm, Let me write it. 2D prefix sum. So what we do is basically, okay, let's say we have to find out, let's say we have our values, okay, so let's say each grid value contains some of all the elements above it, and uh, yeah, that's all. So for example, this grid, this value will contain some of all the elements of this square. This element will, this position will contain a sum of all the elements from this to this, from this to that. Okay, and similarly, this will contain some of all the elements in this section. Okay, once we have that, let's say we will see later that we can get the sum of the required square. Okay, now how to calculate this thing first? Let's talk about that. Let's assume that what we want, right? What we want this position to capture the sum of all the elements above it. Okay, let's assume for now, like we have the, to calculate this thing, we have value for this one, we have value for this one, and we have value for this one. Okay, so let's mark them with some colors. Okay, that will be very helpful, I guess. uh, let's say this is green, let's say this is blue, and let's take another. Which one should we take? Let's take this orange. Now, okay, we have to calculate this thing. Okay, to calculate this thing, we have values of these three elements. Okay, so I will draw the squares. Please watch it carefully. So for this thing will contain square from this to that. Okay, will contain the prefix sum of that, and this thing will contain the square of this to that. Okay, and the blue and the blue thing, sorry, okay, and the blue thing will contain this thing. Okay, now as you can see, to get the value of this position, we will sum up. It will be what, value of the above point, so it will be grid of, so let's say our prefix sum array, prefix sum matrix, it's called as pref. Okay, so pref of, we have to calculate pref of ij, right? Pref of ij will be equal to mat of ij. Mat of ij is basically the current value on this element, on this position in the original matrix. Then it will be plus this thing. Okay, we sum this thing, we want the answer of this thing, right? The whole square from this to that. So how will you calculate that? So first we got this, then we will do pref of I minus 1 j. So basically this green part. Okay, this is I minus 1 and the column is same, so that's why. Then on the left hand side, we will sum that as well. So what is this position, right? The row is same, but the column is 1 minus. So it will be ref of I and j minus 1, and plus, what about this thing? Okay, so now up till now, let's think what is summed up. Okay, so we have not taken the blue part, so let's erase the blue part. As you can see, there is an over, so we sum up this thing, we got this, we added this thing. Now don't you think this portion, which is a blue portion, in fact, it got added twice. Okay, as it has been added twice, we will subtract it. Okay, so let's subtract it. We will require to subtract it how many times? It will be subtracted only one time. Okay, and this element represents this thing. Okay, mat of ij. Now as we saw that, we just have to subtract f of I minus 1, then j minus 1. Now we have all the values over here. Okay, now it becomes very simpler for us. We wanted to calculate the sum of square, right? The sum of any grade. So let's say we want to calculate sum of this grade. Okay, how would you calculate that? So first of all, what we know, let's talk about this point. Okay, for this point, what we know is, okay, we have value of this whole grid. Let me put the error. Where is the laser? Okay, so for this point, okay, for this point we have this value of whole sum. Okay, now to calculate this, this grid, what to do? So first of all, let's take this whole thing. Okay, let's imagine that we got the sum right in the prefix array. Now subtract this value, this blue value. Okay, this we will subtract this value from it. Okay, then we can subtract this value from it. Okay, and then we will get our answer, right? We'll get our inside answer. But don't you think again this portion got subtracted twice? So what I am saying, so there will be multiple variables. So first of all, here we will have int. Okay, sorry for that. First of all, we will have some total. In total will be equals to pref of ij. I mean pref of, as we saw that this is the right, we want to calculate this for this square, right? What was this point? As we saw previously that it was something like I plus x, j plus x. Okay, so it will be ref of I plus x minus 1. As I said earlier, like they are not uh you know endpoints, they are not included. Okay, this is my total, and let's call this upper blue part as up. Our up will be pref of, what is this value? Okay, this is just above this row, so it is I minus 1. Okay, as you saw for this point, what was our uh, what was our coordinates? It was I comma j plus x. Okay, so we will require just above ones. Okay, so pref of I minus 1, and this will be j plus x minus 1. Okay, and what about the down ones? I mean the left ones. Okay, I'm referring left one as this thing. So similarly, it will be pref of, as you can see, this point was I plus x comma j, right? This was I plus x comma j. So its value will be I plus x minus 1 and j minus 1. All right. I hope you got this. And now, what about the common part? Our common part will be pref of, this was the common part, right? And this was subtracted twice, so we want to add this. Okay, so remember that. our common part will be, what was this point? This was I comma j. So this will be pref of I minus 1 comma j minus 1. So basically on the left it is j minus 1 and on the up it is I minus 1. Okay, we got this. And our final sum will be, it will be total. So basically this total portion, let me draw it once again for you. Okay, I wanted to calculate this thing. Okay, let's draw some squares. We got this total, right? Then we will subtract up from it. That means the upper part, which is this one. Okay, then we will also subtract the left part from it, which is basically this part. Now, as you can see, this portion, like this portion got subtracted twice, right? So we want to add it once. Okay, so what is this portion basically? So it is just prefix value of this position, which is I minus 1, j minus 1, which is stored in the common part. So we want to add the common. And yeah, if this sum is less than equals to x, less than equal to threshold, we got our answer. Our answer will be x. Okay. Okay, that was all for it. You can see my solution like this. Okay. Right. Okay. We let me get to the editor. As you can see, we first defined a prefix sum, prefix matrix. So to calculate the prefix matrix, we get the current value. We will implement the same thing as we discussed over here, right? So as you can see, it is pref of ij is equal to mat of ij plus pref of I minus 1j, and then ij minus 1 minus I minus 1 j minus 1. It is the same thing implemented in the, you know, by defining the variables up, left, common. And if, note that if they, uh, if there is an, if the index overflows in some way, like if I minus 1 becomes negative, there can be a definite possibility. So we will make the sum as 0. We'll take that sum as 0. Otherwise, we will take the prefix value on that. Okay, then we saw that it will be current value, which is mat of ij, plus the up value, which was basically the upper part, just the upper index. I minus 1 j. This is I comma j minus 1 value, and this is common part which was added twice, so we want to subtract it once. And this is the important part. We iterated from the minimum of n cross n comma m to length greater than 0, or maybe we can say length greater than equal to 1, length minus minus. Then for int I is equal to 0, we so basically for each length we want to find out. So we first got two indices I and j. So what will be the right thing? Right coordinates, right? So the right coordinates will be I plus len minus 1 and j plus len minus 1. J is x is for row, this is for row, and this is for column. Now to find the total sum, we will do the same thing. What was the total? Total was pref of dx dy. We got the up, we got the left, we got the common part, and then we got the whole sum. Total minus up minus left plus common. uh, total minus up minus left plus common. Okay, this was what discussed. And if the threshold is something like this, then we'll directly return the length. We don't need to go down. And finally, if we don't find anything, we'll return 0. Now let's try to submit the solution. As you can see, it got submitted. Now, to why this bit's only 12.27%, right? Because we have not used binary search over here. So you can think upon the binary search approach. It's open to all. Thank you so much.